Demonstration problem. Find forces A and C in the diagram below, assuming the system is in equilibrium. We know the direction of vector A is 19 degrees. What we really need to find is the magnitude of vector A. We also know the direction of vector C is out the negative x-axis. We need its magnitude. We're given that vector B is along the negative y-axis with a magnitude of 626 newtons. Given, we have that the system is in equilibrium, which means that the forces are balanced along both axes and the body is either at rest or moving with a constant velocity. We know that angle A has unknown magnitude at an angle of 19 degrees, as depicted. Angle B has a magnitude of 626 newtons. Its angle is due south. Angle C has unknown magnitude and its angle is to the west. The unknown, we need to find the magnitude of vector A and the magnitude of vector C. The equation f net of x is a sub x, or the x component of vector A, plus b sub x plus c sub x is 0. F net of y, or the sum of the y force components, is a sub y plus b sub y plus c sub y, and that is also 0. To find the force components, we use trigonometry as before. A sub x is plus or minus, where that is manually prefixed depending upon the quadrant, magnitude of vector A, times the cosine of the reference angle theta ref. A sub y is plus or minus magnitude of vector A times the sine of theta ref, the reference angle. Substitute. F net of x is magnitude of A times the cosine of the reference angle 19 degrees. In the first quadrant, the reference angle is just the angle. Plus 0. B, since it is due south, has 0 x component, minus the magnitude of C. C points out the negative x-axis, and therefore its x component is negative. F net of y is a sub y, which is magnitude of A, times the sine of 19 degrees, plus b sub y. B sub y points along the negative y-axis. Therefore, its component is all negative y. So that's plus a minus 626 newtons, plus c sub y. C sub y is 0, since vector C points out the negative x-axis. This is all equal to 0. Solve. We have two linear equations in two unknowns. The unknowns are the magnitude of vector A and the magnitude of vector C. Our game plan is to solve this equation explicitly for the magnitude of vector A. Once we've done that, we can substitute in the magnitude of vector A into this equation and then solve explicitly for the magnitude of vector C, and then we will have the problem solved. From this equation, we get that magnitude of A times the sine of 19 degrees is 626 newtons. Solving, we get that magnitude of A is 626 newtons divided by the sine of 19 degrees. Since this is a 3 significant figure problem, we carry 4 significant figures in intermediate steps. We record magnitude of vector A is 1923 newtons. We've now solved the problem. Since the givens are 3 significant figures in accuracy, we can only report 3 significant figures in our answers. Therefore, we report that the magnitude of vector A is 1920 newtons and the magnitude of vector B is 1820 newtons.